Good morning, good afternoon. Today we're going to be talking about 2.1, or Chapter 2, Lesson 1. Our I can statement is I can solve one-step equations in one variable. That means that it will only have one variable, and you're going to be solving it. We talked in the last chapter with thinking of it logically or mentally, thinking what plus 5 equals 12, or whatever, and solving it that way. Well, now we're going to have to be showing all your work. Okay, big thing first. Your goal when solving an equation in one variable, again, in one variable only means that it just has one variable. There are not there's not an x and a y. It's only an x or a y. Okay, so your goal is always to isolate the variable. You want to get it by itself. That means that there is no coefficient on that variable. So circle the equations that the variable is isolated. This one is that, just say yes or no. First one. No. No, because we have a 4 in front of it. What about the second one? Yes, we would circle that one. What about this one? No, because we have that variable being divided by 3. What about this one? Yes. Oh, that's an yes. That's a circle. Because our x over here is by itself. It doesn't matter which side it's on, it just needs to be by itself. Okay, so our inverse operations are going to help us. I need to undo what's being done to the variable. So how do you undo adding? Subtract. How do you undo subtraction? Add. How do you undo multiplication? How do you undo division? Yes. So those inverse operations are going to undo each other. Addition and subtraction undo, multiplication and division undo. Okay, these properties of equality. I know that we did the Quizlet Live and they look kind of funny when you're looking at them, but what this is saying is, if you're saying two things are equal and you add the same thing to them, are they still equal? Yes. Meaning I give two people $5, okay? And then someone else gives them $5. Do they still have the equal amount of money? No. Yes, they both have $10, right? It's just on equal, if we have adding two things to each side of your equation, it's still staying equal. Other thing, whatever you do to one side of your equation has to do to the other. That's big. Whatever you do to one side, you have to do to the other. Did you want me to go back? Sorry, that was quick. Okay, so wherever I have that equal sign, some people like to draw a line of some sort. Railroad tracks, but there always has to be an equal sign in here, right? And they have to stay equal. So I have to undo what's being done to my variable. So what is being done to my variable? I'm adding 2. So how do you undo that? Subtract 2. Again, we have that, we talked about last chapter of our, when you your identity property of addition. What is that? Remember? No, not necessarily. That's our commutative. Identity property of addition. Identity property means that
if you add, it's the same. Its value to it. If you're subtracting, it's like automatically 0. But if you subtract its value, like its same value, it's 0.
Close. I think you're on the right track. So when we get to 0, we're saying that y plus 0 is just y, right? That's that identity property. So if we subtract 2, 2 minus 2 is 0. So now we have gotten y by itself. Yes, it's plus 0, but we're not changing anything. That's the y behind it. You don't have to do that every time. Now, my property of subtraction property of equality means that if I do something on this side, I have to do it to the other side. So I like to cross these out, that they're gone. Plus 2 and minus 2, or it's a zero pair, it'll go away, right? So I have y left, negative 6 minus 2, negative 8. Okay, if I have a negative 6 and I subtract or go even more negative, it has to go to the left 2, right? So there I have y equals negative 8. Now you want to check your answer. Y plus 2 equals a negative 6. I'm going to put what y is into my equation. Plus 2 equals a negative 6. This is where I want to solve or simplify both sides of my equal sign. Negative 8 plus 2 is a negative 6. This has to become a true statement. It checks out. So it is true. So I know that my answer is correct. Okay. Here, what is the solution? What's happening right now to x?
Also, on our homework check, do we need to like check the answer? We just need to
Check the answer too. Yeah. It's being multiplied right now by 15. So I can undo it by dividing by 15. Because 15 divided by 15 is 1. So I get 1x equals, now, whatever, again, I do to one side, I have to do to the other. So divide this by 15. What do I get? I get a fraction, right? 10 over 15. This can be reduced down to 2/3, right? So 1x, this is that identity property of multiplication where anything multiplied by 1 is itself. So this essentially is just x, and I've isolated. Isolating my variable means 1x or just x. I don't care what you put. If you leave it as 1x, that's fine. No. If it starts as a fraction, leave it as a fraction. Okay? So 2/3 is equal to x. I would go back and I would do 10 equals 15 times 2/3. This is what we did last chapter. If it starts as a fraction, because 2/3 is a decimal and it's a repeating decimal. If you convert it to a decimal, your number will be just slightly off because it is a repeating decimal. Unless it's a terminating decimal, that's different. But if it starts as a fraction, end it as a fraction. So this, remember when we have fractions and we're multiplying, you want to multiply, put it over 1, multiply across the top, across the bottom. I can simplify before, so 15 and 3 both be divided by 3. So we get 5 times 2 on top, 1 times 1 on the bottom. So that's 10, right? 10 equals 10. That checks out. What's happening to my variable of r? It's being divided. I have to multiply both sides by 3. Because 1 on top and bottom will cancel out, right? I'll just have r left. And then 3 times 19, anybody play darts? 57. Triple 19 is 57. Then I can check it. 57 divided by 3. Oh, does that equal 19?
Yes.
Yes, it does. It checks out.
I just like 9 times 3 is 7 plus 10 times 3.
Okay? Let's do a few more. I'm going to subtract 3 from both sides. You don't have to show these every time, but I like to show that negative 3 equals negative 3. I'm staying equal the whole time to whatever I do. This goes away. Y equals 7. Does 7 plus 3 equal 10? 10 equals 10. It checks out. I also want to reiterate that whatever it is over here, because we're going to start getting into some harder problems where I want you to know that, so I have to just look at what's happening there. So if I had negative 2 minus x, or 2 minus x, let me actually change it. I'm gonna do it over here real quick. So we have, say, 2 minus x equals 5. So right here, remember this, I think I showed this in an example last week, where you look at this and a lot of kids will say, oh, I have to add the 2 to both sides, right? That's incorrect, because if I add 2 to 2, that will get me 4. My goal is to get 0, right?
Yeah, so you want to subtract that.
So I want to subtract it.
Wait, but then, so are you then left with negative x?
Yes. You have to keep that negative with that x. Okay? Let's go back to this one because I just wanted to show that real quick. But, so I add 2. I get negative 1 equals x. And then I can put negative 3 equals negative 1 minus 2. Is negative 1 minus 2 negative 3? Yes. Divide both sides by what? 4. Negative divided by a positive is a negative 6. And then I can do negative 24 equals 4 times a negative 6. Negative 24 equals a negative 24.
We have to show that we checked it.
Yep. We already asked that. What do I do to this one now? Multiply by 4. Because these will cancel out. Multiply this by 4. H equals 20. 20 divided by 4 equals 5. 5 equals 5. Doesn't take very long to check it. Okay, when you are multiplying by a fraction like this, you're going to multiply by the reciprocal. And again, the reciprocal is, you're flipping it. So this is actually 1/4 h, and we would multiply it. So h divided by 4 and 1/4 h are the same thing. So just remember that. But here, if I see that I have 3/4 x, to get rid of that, I want to multiply by the reciprocal. So I would multiply by 4/3, because reciprocals when multiplied together equal what? 1. And that's my goal, to get a coefficient of 1 on my variable. So this would go away, right? And I have 1x, but I can't forget to do it to the other side. So I have 12 over 1 times 4/3. 3 and 12 can both be divided by 3. 1, 4. 4 times 4 now is 16 equals 1x. Check your answer. 12 equals 3/4 times 16. 4 and 16 can be divided by 4. 1, 4. 12 equals 12. I'll go back in a second. Okay. Nope, that's one we just did. Word problems. You want to define a variable. Yes.
So you have to multiply by reciprocal, you just put divided by 3/4.
You can, it's the same thing. Okay. So on your notes, right here, you want to define a variable. I don't think it's in my notes for some reason. Define a variable. And then write an equation. And then solve. So defining a variable means that a variable varies, right? Oh, I have 5 seconds left. Okay. Do your homework.